replacing null values in the column item weight with mean weight. Replacing null values in the column item visibility bins with low vis. Display the data once. Let's create dummies for outlet type. Dropping the irrelevant variables. Now that we have the data ready, it's time to start making predictive models. Instantiate the regressor using the code on the screen. Importing the sklearn libraries for model selection. From sklearn, import model_selection. Creating train test split. Let's find out the coefficient and intercept of the line. Code is on the screen. Using xtrain and ytrain for linear regression. Let's find out the RMSE for the model. Print the root mean square. A good RMSE for this problem is at least 1,150. Using ridge, lasso, and elastic net, we can find out the RMSE and R2 values. Importing the ridge model from sklearn. From sklearn.linear_model, import ridge. Initializing the ridge variable with the alpha set to 0.001. Fitting the model on xtrain and ytrain. Printing the root mean squared error. Printing the R2 value. Importing lasso model from sklearn. From sklearn.linear_model import lasso. Initializing the lasso variable with alpha set to 0.001. Fitting the model on X train and Y train. Printing the root mean square error. Printing the R2 value. Importing elastic net model from sklearn. From sklearn.linear_model import elastic net. Initializing the elastic variable with alpha set to 0.001. Fitting the model on X train and Y train. Printing the root mean squared error. Printing the R2 value. Let's quickly recap the steps we covered. We started by making some hypothesis about the data without looking at it. Then we moved on to data exploration, where we found out some nuances in the data which required remediation. Next, we performed data cleaning and feature engineering, where we imputed missing values and solved other irregularities, made new features, and also made the data model friendly by one-hot coding. Finally, we built regression models.